Okay, so now we want to construct a grammar for logical formulae with n many variables, x1, x2, all the way up to xn, and depending on how you define it, either 4 or 5 operators, depending if you count brackets as an operator. I wouldn't, so 4 operators, negation, logical and, logical or, and implication, such that the order of precedence here is satisfied. So negation binds tightest, then ands, then ors, and implications. So this statement here, when you actually do the past tree, should be evaluated strictly in this order. So have a go constructing the grammar for a language. So the language is a set of all strings that are logical formulae with respect to this order of precedence. Have a go constructing a grammar for it that's unambiguous and respects the order of precedence. And then we'll go through that together. So pause the video, have a go at that now. Okay, I'm going to assume we did that. So what do we have to do? So first things first, we always have to ensure that the things with lowest precedence are always evaluated first. They're always in the highest layer in the grammar. So from S, I want to be able to put in implications, but I can't go S implies S because then I can there's 2 different paths to take. Also, I can see why this would be hard to read because we're using the arrow twice. I'm going to use a boldface implication just so it's a little easier to read. There we go. So what can S go to? Well, we want it to be left associative, so I want to go down the left-hand side, except for the case of implication. So when we have ands and ors, so when I write x1 and x2 and x3, it's normally left associative, and it doesn't really matter because logical and is associative, but we usually write left associative, except in the case of implication. When I write x1 implies x2 implies x3, I really actually mean this. So I should have specified that and is left associative, or is left associative, and implication is right associative. So I fibbed a bit there, so maybe have another crack at this question with this additional bit of information, and then we'll go through it. Okay, so how are we going to do this? So we want to do the negations first. So S can either go down to the next layer, or it can down to the next layer with a negation in front. Okay, so negations, sorry, what am I talking about? I want to do the implications first, my mistake. So if we want to do implications first, I want implication to be right associative. That means I want to be able to branch on the right-hand side. So that means I should have S goes to T implies S or T. So when I draw my pass tree out, T implies S, it's going to be right associative. It's going to do the rightmost implications first. Okay? T is going to be the layer for ors, and or is left associative, which means I want to go branch down the left-hand side. So I can go to T or U, or I can go to U. So that way, if I'm in T or U, T or U, and it's going to be left associative because you're going to evaluate the left-hand side ones first. And then U is going to do AND, so we can do the same trick again. So when I branch on the left, so U and W or W. And then W will do so for unary operators, only operate on one thing. You can either do it or you don't have to do it. So W can either skip down to the next layer or add a negation and then go down to the next layer. So it can be negation of V or V. And then V can be the variables or go back to the start with brackets. So V can be X, which will be collection of variables, or go back to the start in parentheses. And then X can go to x1 or x2 or da or xn. Okay? So this grammar is unambiguous because I can only branch down one side, and it respects the order of operations and the order of which binds the tightest, which binds the weakest, and it respects the associativity of the operators. So and or are left associative, whereas implications right associative. So if I try and have some logical formula, so not x0 and x1 and x2 implies x3 implies x4, the pass tree for this should be do the negation, do the leftmost and, then I'd do the other and, but then do this implication first. So it should hopefully evaluate them in this order. So let's try to build it. So S goes to T implies S, and then this S is going to be another implication. T implies S. I don't want to add any more implications. This S is going to go to X false, so you just follow the chain down. S goes to T, goes to U, goes to W, goes to T, U, W, V, X. T, U, W, got my alphabet in the wrong order, that's okay. X, and then X4. There we go. And then what I want for this T, I want X3, so I follow the chain down. U, W, V, X, X3. And then here I'm going to want my add my ands. So I'm going to skip the OR, so T will go straight to U. And then I'm going to add the ands. So U goes to U and W. And I want to add another and, so this U will go to U and W again. This W will fly down to X2, so W, V, X, X2. This W will do the same, W, V, X, X1. This will do the same, but it adds a negation along the way. So U goes to W, goes to not V, V goes to X, goes to X0. And I apologize for the sort of slanted tree, but then I had to fit it all in. So we can see it's unambiguous. Again, the grammar, the parse tree for this is quite large compared to if I just done this naively and not care about the ambiguity. So if I just like done this naively, what would I get? I guess S goes to not S, or S and S, or S or S, or S implies S, or X, and X is X1, or da 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 da, or Xn. So if I wanted the same parse tree under this one, again it'll be ambiguous. There's many ways to draw it, but it's going to be much shorter, right? So I could just chuck in the implications immediately, and then chuck in more implications, and then send that to X to X3, send that to X3, and this S I want to add ands, so S goes to S, and then I can branch the opposite direction and completely fail the whole point of the order you're supposed to do these in. S, and then do the negation, not S, X, X0, X, X1, X, X2. So you can see this will do the right hand and first instead of doing the left hand and first, which is not what we want. And also, here I've respected the fact that the implication is right associated, but I didn't necessarily have to do that. I could have branched the implication left hand side and also stuffed that up. So I could have gone S, S implies S, and then done the second implies here instead. And then this will go down to X3, and this will go down to X4. So I can totally draw a parse tree for this same string, such that it evaluate in some kooky order. I guess it'd be negation X0, and X1 and X2. And this whole thing implies X3, and then that whole thing implies X4. And these two statements are clearly not equivalent, right? So it's really important that our parse trees be unambiguous, because when I want a computer to evaluate this, the computer doesn't evaluate the string. It evaluates your parse tree. So if your parse tree is ambiguous and you evaluate things in the wrong order, clearly you're going to get a different answer, right? If I write down negation of true or false, you could interpret that as not true or false, or not true or false. You're going to get different answers, right? Not true is false, false or false is false. True or false is true, not true. Okay, well in this case you get the same answer. Let me think of one where it does work. Here we go. Not false or true. So once again we've got two ways to do it. So in the first case we get not false, which is true, true or true is true. Here we get false or true is true, not true is false. So now they don't agree, right? And so why? Because presumably the grammar for this is unambiguous, and that means I can get different parse trees. So it's really important that your parse trees don't have ambiguities in them.